All right. Welcome back, guys. Good to see you again. And we are going to continue with graphing. All right, and we're going to graph cube root functions. So we moved on from square root to cube root now. All right, so our I can statement is I can graph a cube root function and its transformations. All right, so to define this, a cube root, this is a function that has a cube root in it. And that's it. All right, so in that box below it, all right, we have the parent function g of x equals the cube root of x. And you can kind of see some of the points. All right, I'm going to give you, again, 5 points that would be really, really good to use. All right, so for g of x, -2, -1, 0, 1, and 2. And then when you cube all 3 of these numbers, that's how you find your x. So -8, -1, 0, 1, and 8. Okay, so we always start with this. All right, domain and range for this are really nice because they're all real numbers. All right, and then transformations. All right, the transformations for cube roots are the same as transformations for square roots. All right, so H moves the graph left to right. K moves the graph up or down. All right, A vertically stretches. The graph when A is greater than 1. A vertically shrinks. The graph when A is between 0 and 1 if it's a fraction. And if A is negative, all right, then the graph is reflected over the x-axis. I did not put any of that on there. Sorry. B horizontally shrinks. The graph, if B is greater than 1, B horizontally stretches. The graph, if B is a fraction, if it's between 0 and 1, and if B is negative, we flip it over the other axis, which is the y-axis. All right, so the same exact rules as we had before. All right, we're just dealing with the cube root now instead of a square root. Okay, so we're just going to go ahead and jump into some examples of transforming it. All right, and again, remember what we did last time with what affected which part of our graph. All right, so we have the cube root of x minus 4. So because this minus 4 is on the outside, it affects our f of x. So -2, -1, 0, 1, and 2. -8, -1, 0, 1, and 8 for our x. All right, and then I'm just going to need to subtract 4 from all of these. So -6, -5, -4, -3, -2. All right, and now I can plot these points. All right, so -1, 2, 3, 4, 5, 6, 7, 8, and then -6, 1, 2, 3, 4, 5, 6. Right there. All right, then I go to -1, -5, then I go to 0, negative 4, then I go to 1, negative 3, 1, 3, 4, 5, 6, 7, 8. And that's it. So once you plot those, okay, that's it. 5 points that you plotted, and your graph should look very similar to that. So then transformations, we only had one. That -4 out back made us go down 4. All right, and that's it. Easy as that. All right, next example. All right, we have the cube root of x minus 5. All right, because this is underneath, all right, it affects our x. And remember, because it's with that x underneath the root, all right, it does the opposite. So we're really going to add 5. So -8, -1, 0, 1, 8. All right, I just add 5. So -3, 4, 5, 6, and then 13. All right, and then f of x, because there's nothing behind or in front of our radical, those stay the same. -2, -1, 0, 1, and 2. So then those numbers and those numbers are the ones we use to graph. So -1, 2, 3 goes to that -2. And then 1, 2, 3, 4 goes to -1. 5, 0. 6, 1. And then we're somewhere over here. So I'm going to draw my graph like that. And I'm done. All right, we only had one transformation. All right, that -5 made us do what? It made us go to the right 5. All right, so hopefully pretty self-explanatory so far. All right, but you have one try it yourself. All right, so remember the rules. All right, we're going to come back once you're done. All right, so we're back, and we're going to keep on going with the next example. All right, so we have the negative cube root of x plus 2. So remember, this plus 2 goes with that, and this negative goes with our f of x. So the negative really means we're multiplying all those numbers by -1. So -2, -1, 0, 1, and 2. I'm just going to multiply all those by -1. So it'll be 2, 1, 0, -1, -2. All right, over here, all right, remember we have to do the opposite. So I have to subtract 2. So -8, -1, 0, 1, and 8. I'm going to subtract a 2 from all of those. So -10, -3, -2, -1, and 6. So I'm going to use these and those to graph my cube root function. So -10, 2, -3, 1, -2, 0, -1, -1, and then 1, 2, 3, 4, 5, 6, -2. All right, so this time, all right, two things happened. All right, that negative made us flip over our x-axis. All right, and then that plus 2 made us shift our whole graph left 2. All right, and that's it. Those are the only transformations that we have. Capiche? Hopefully. All right. On to the next page. All right, we have one more example, and then some try-it-yourself problems, and then one more example. So we're almost there. All right, so we have 2 times the cube root of x minus 3 plus 4. Okay. So this 2 and this 4 both affect our f of x, and that minus 3 affects our x. So that really means we need to add 3 to our x values. So negative 8, negative 1, 0, 1, and 8. I'm going to add 3. So negative 5, 2, 3, 4, and 11. Alright, our f of x, negative 2, negative 1, 0, 1, and 2. I'm going to multiply it by 2 first, and then plus 4. So I'm going to double these numbers and then add 4. So negative 2 times 2 is negative 4, plus 4 is 0. Negative 1 times 2 is negative 2, plus 4 is positive 2. 0 times 2 is 0, plus 4 is 4. And if you can see the pattern, alright, you should be able to figure out the rest. I'm going to circle these to let me know what my coordinates are. So negative 5, 1, 2, 3, 4, 5 is at 0. Alright, positive 2 is at positive 2. 3, 4, 4, 6, and then 11, which is over here, goes to 8. Okay, so this time we had 3 transformations. Alright, so we're going to go left to right. So this 2, alright, if you notice, it's a lot taller. So this was a vertical stretch. Alright, that minus 3 affected our x, so we had to add 3, which means we went 3 to the right. I'll write 3. And then, alright, this plus 4 made us shift everything up 4. And voila. Alright, so now you have a couple of problems. I believe you only need to graph one of them. Alright. And then the other two, you just have to figure out what the transformations are without having to graph it. Alright, and then we'll be back for the last example. Alright, so now we're on the last example. Alright, so it says the shoulder height h in centimeters of a male Asian elephant can be modeled by the function h equals 62.5 times the cube root of t plus 75.8, where t is the age in years of the elephant. Use Desmos to graph the function. Alright, so what we're going to do is I just rewrote them so they're a little bit easier to understand. So I just replaced h with y and t with x. Alright, so I'm going to plug it in, and I already did. Okay, so if you notice, alright, I typed it in exactly as was on the equation sheet. And now what I'm going to do, alright, they wanted to figure out how old the elephant was after, or when he reached 200 centimeters. Alright, so what we do, if I can find my mouse, alright, we're going to zoom out. Alright, and we're going to look at where they intersect. And we look at the x coordinate. Alright, so that's our answer right there. So 7.8 years. And that's it. That is our answer. Okay? If you're confused as to how to find this cube root, alright, you go down to your keyboard, and then you go to functions, and then you go to miscellaneous, and it's right there. And that is it for this lesson. Let me know if you guys have any questions about anything. Gladly answer them. Alright, so please let me know, and I'll see you guys in the next one. Peace.